Hey everybody, it's Wojo, and today we have our last set of exponent properties. We're going to talk about zero, what anything to the zero power is. We're going to talk about this idea of a negative exponent. And so we're going to start with something kind of real simple, and that is basically this definition here, that anything to the zero power is equal to 1 by definition. And then I have this little note over here that says x cannot be 0. So the only thing that's not to the zero power that's 1 would be 0 to the 0. 0 to the 0? Not 1. Everything else to the 0 power is 1. So if you didn't believe me, you could grab a calculator and you could try 5 to the 0 and you would get 1. You could try negative 256 raised to the 0. I gotta be careful of this. Negative 256 raised to the 0 power, and it will also be 1. No matter what number I do, 3/5, so even a fraction raised to the 0 power would still be 1. The only problem is if I raise 0 to the 0 power, the calculator gets a little mad at me and says domain error. But by definition, anything raised to the 0 power is equal to 1. And so when you're simplifying properties, you got to kind of keep that in mind if you see something with the 0 power. So this first example says simplify 4x squared y to the third, all raised to the 0 power. So in this problem, who gets the 0 power? Well, everything in the parentheses. So since everything gets raised to the 0 power, we said anything to the 0 power is equal to 1. So this answer would simplify simply to the number 1. Not x to the 1, but just the number 1. So students see that quite often. They go, oh, that's pretty easy. Anything to the 0 power is 1. So they'll come to example 2, and they'll say, okay, so 4x to the 0 is equal to 1. And I'll go, wrong. And what it comes down to is you got to be very careful again about how you read the math that you're looking at. On this problem, who did that 0 power belong to? It belonged to everything. In this problem, who does that 0 power belong to? And so it's all about kind of how you read this. This is 4 times x to the 0. This 0 power only belongs to the x. If they wanted it to belong to everything, they would have put parentheses around the 4x. So in this case, this 4 is still a 4 times, what's x to the 0? Well, anything to the 0 is 1. But what does this problem simplify to? It doesn't simplify to 1, it simplifies to 4 times 1. And so in this case, this answer would be 4. So it's real important you see the difference between these two problems. Here, the 0 power only belongs to the x, so pretty much it's like it's not even there. And that's what you'll see a lot of times. They'll just get rid of it. It basically does nothing. But that 4 doesn't go away because that 4 is still there. So 4 times 1. Where in this one, if I gave the 0 to all of these, that would turn into a 1, that would turn into a 1, and that would turn into a 1. 1 times 1 times 1, still 1. And then, of course, is my favorite 0 power problem, super, super difficult problem. If I asked you what 5 to the 0 plus 3 to the 0 is, and I just had you think about it, hopefully you come up with, oh, that's easy. The answer is just 2. Basically, all I'm asking you is what is 1 plus 1? Because what is anything to the 0 power? What's 5 to the 0 power? 1. Plus, what's 3 to the 0 power? 1. What's 1 plus 1? It's equal to 2. So the big takeaway today, though, is what is anything to 0 power? It's equal to 1 by definition. The only time that's not true is if x is 0. 0 to the 0, we say domain error. Whatever, that's what the calc says. Alright, so now that's anything to the 0. Now let's talk about this idea of negative exponents. So again, by definition, if you read a basic textbook, they'll say something like this. X to the negative 1 is equal to 1 over x. It's the reciprocal of the x, or it's the flip, or whatever. And they'll write something like this, and then they'll say, got it, good. But for a lot of students, they don't get it. They're not 100% sure what that means. And so I usually talk about it a little bit differently, still keeping in mind that definition. But I look at this as x to the negative 1 to me really is, there's one of those x's, it's x to the 1. And that negative power just tells me that that x is in the wrong spot of the fraction. So if you think about x to the negative 1, if you think about it as a fraction, the x to the negative 1 is in the numerator. If you wanted to put a denominator there, you could put a 1. But what this tells me is this x, this positive 1x, is just in the wrong spot. So if it's in the numerator, it just moves to the denominator. Once you move it, it becomes positive. And once it's gone, if there's nothing up there, it's just 1. So this will just become 1 over x to the 1 or 1 over x. But I like to think of negative exponents just that they're in the wrong spot. That if they're in the numerator, they're really supposed to be in the denominator. If they're in the denominator, it's supposed to be in the numerator. So if I look at simplifying some of these problems, one of the things you'll notice is most textbooks, or actually pretty much every textbook that I know, says all answers should not contain negative exponents, that you can clean that up. And so if I see a problem like this, I'm going to say, all right, well, I have my fraction bar, and the 3 is there, and I would look for things that are in the wrong spot. And I can tell if they're in the wrong spot because they have a negative exponent. So this is a negative 2 exponent, and so I would just take that a, realize there's 2 of them, and I would move them to the denominator. And so the a's would come down here. So when they come to the bottom, they're just going to be a regular a squared. It was an a to the negative 2 at the top, move to a positive a to the second at the bottom, because all the negative tells me is in the wrong spot. Once I move it to the bottom, it's not in the wrong spot, so I don't need the negative sign anymore. Keep going on this problem. So I took care of the 3, I took care of the a squared. B to the 5th, that's positive. It's not in the wrong spot. It's just going to stay right where it is. Okay, took care of that. And I keep looking. Is there anything else that's out of place? Well, I look at the denominator here and notice it says c to the negative 3. Well, again, what does a negative exponent mean? To me, it means it's in the wrong spot. So if it's in the bottom and it's in the wrong spot, that means it's going to have to move up to the top. And so when it moves to the top, I still have those 3 c's. But once I move them to the top, notice they go from negative to positive, because the only reason it was negative, it was in the wrong spot. It's the flip of it. And so I took care of that. And the d's, they're positive, so they're not in the wrong spot. They're on the bottom. They're in the denominator. And so I'll just move them to the bottom. And this would be the simplified version of that. That would be me getting rid of the negative exponents. Notice all I did is I took the 2a's, the a squared, moved it to the bottom. I took the c to the 3rd, moved it to the top, just got rid of the negative sign after I moved it. Nothing else really to do. They can get more complicated, and so I wanted to talk about a little bit more complicated. If you wanted to simplify something like this, pretty straightforward. Just got to be careful that you don't mix up things with what you've already learned. I just told you negative exponents are in the wrong spot. What I'll see students do is I'll see students look at this negative 2 and think they have to move it to the bottom. But if you look at it, does this negative 2 have any exponent at all? No. And so it doesn't have any exponent. It certainly doesn't have, well, it could be to the 1st power if you want to think of it. But that's not a negative exponent. So this negative 2 has to stay. This idea of negative exponents only applies to the exponent, that little number. If it doesn't have an exponent, then you can't apply that rule, because those rules aren't for coefficients. The numbers by themselves are called coefficients. But we could say it belongs to this, x to the negative 2. What does that negative 2 tell me? It tells me it's in the wrong spot. So where do these 2 x's belong? They got to move to the bottom. Now when I move them to the bottom, if I wanted to write it down here, notice I already have some x's in the denominator. I already have some x's. So when I go to simplify it, how many x's do I have multiplied together total on the bottom? I have 2 and then 4, so a total of 6. Remember, x squared times x to the 4th would simply be x to the 6th. You add them, add the exponents when you're multiplying because of that repeated multiplication. So I look here and I say, all right, move those 2 to the bottom. There's already 4 on the bottom. 2 on the bottom plus the 4 I already had makes a total of 6. So that'd become x to the 6th. So I've taken that negative 2, I've taken the x, and I've taken the x. Now I keep looking. Notice that I have a negative y. Can't have negative y's. They got to be positive. What does that negative tell me? It tells me it's in the wrong spot. So in my head I'm thinking those 2 y's have to come to the top. They're no longer negative now. But how many y's do I have total on top now? I had 3. Now I have 2 more because those 2 moved up there. 3 and 2 make a total of 5. So your final answer would be negative 2y to the 5th all over x to the 6th. And so you could always kind of do things like that. And then again, if you see something like this, sometimes it messes students up because they don't see a fraction. But remember, anything can be written as a fraction if you just want to make it over 1. And so on this one, what needs to move? What has the negative exponents? The a and the c. So your final answer, the 4 would stay, the b to the 3rd would stay, And then where would the a squared and the c to the fifth go? Because they're negative exponents, they go to the bottom. And so you'd have a squared c to the fifth. So that's just kind of a quick overview of what we talked about on negative exponents. As always, if you have questions, come see me. Otherwise, good luck.